it's an early morning today for me. So if I look kind of nasty, I hope you all understand. So welcome to this Sweet Workshop event. And thank you to our hosts, NUS Fintech Society for having us as well. My name is Brian Seong, and I'm a developer relation engineer at Mysten Labs working on Sui. Today, I'm going to give a quick intro to Move and also the Sui platform as a whole. So before we dive in, a little bit info of myself. So pretty much, I work at the Sui ecosystem and developer experience team, focus on the Sui Move language and university relations. I'm also a co-president at Tuba DAO. Tuba is pretty much named Tsinghua University Blockchain Association. So I kind of lead the blockchain association at my university as well. I'm also the education lead at EduDAO. Prior to this, I was working at Polygon as a DevOps engineer. A little bit of my study background, I was a CS undergrad from Tsinghua University. Currently, I'm doing dual degree masters at both Tsinghua and University of Washington. Mostly based in Seattle, Washington. Just got here like a month ago, 2 months ago. Yeah. So here's my Telegram QR code. If you want to chat, feel free to just scan and add my friend, and we can just discuss about anything there. All right. So the talk will break down into 3 main sections. So first, going to introduce the Move language, which was created at Facebook as a safe, asset-oriented smart contract language. This base version of Move is also sometimes called the DM style Move. So this will be the Move that you see, pretty much in other projects. The majority of the so-called Move projects, they will be using this style of Move language. And then second, I'm going to introduce this very specific branch of Move named Sui Move. This is more like a dialect of Move that was developed by Mysten Labs that combines Move with an object-oriented data model and also enhances the base version of Move in a number of other ways as well. And then lastly, I'll talk about the Sui system. I'll give a quick intro of the Sui system or the Sui network, which is the blockchain, and which is the transaction and the scaling layer built on top of the Sui Move VM core. All right, first, let's talk about Move. Why did we decide to create a new smart contract language? Why is it that crypto needs safe asset-oriented language? So, as you can see on this slide here, I'm listing some of on the right side especially, I'm listing some of the security incidents that happen in blockchain that are so significant that needs to be fixed, or it's just something that a lot of people have suffered from. These are the events. So the big part of the reason why we want to make Move is because of smart contract safety. From what we have seen so far, not like all the exploits and hacks that happen in Web3 are related to the smart contract language. Some of them are caused by leaks of private key, maybe DevOps area, just more of a human manual errors, but many are related to intrinsic characteristics of the language itself. A more recent example is transit swap. The exploit was possible because of a classic. Yeah. So this exploit was possible because of a more of a classic and widely used design pattern in ERC20 standard. So if you know Solidity, ERC20 is pretty much the token standard. Like if you see like Uniswap tokens or maybe SushiSwap tokens, or maybe just any other those like dApps tokens, they're usually under the ERC20 standards. So this standard, it requires you, if you want to do sort of a dApp operation using these tokens, you first need to approve it, and then you're giving this dApp a smart contract's ability to transfer your assets. So those are the two steps that you need to do. But if the user needs to interact with the smart contract using an ERC20 token, to kind of explain will be like, the approving part, is to approve to the smart contract that they want to interact with, which means like giving them as in like giving the smart contract, the DEX smart contract, or any other those just dApp smart contract that you're trying to interact with, the authority say, oh, I'm giving you the authority that you can transfer or operate my funds. And how much can you transfer? Usually in those DEXs or in those dApps, if you recall from your experiences, you only need to approve once. And then you just keep on interacting the transferring or the swap functions, right? So what does that mean? That means at the very beginning, when you're approving, you have approved the maximum amount that you can approve for, like the entire integer size. So integers like what, 256 sorry, 256 bits. So about that size. Even though you don't have that many amounts of balance under your address, but you can still give them the approval, say, this is the allowance that I give you to transfer my funds. So as long as your approval your approval amount is larger than my balance itself, that means you can pretty much just transfer any funds, like any amount of funds under my address to within your needs. So that's like what approve really does here in most of the projects. So once the smart contracts centralized, not centralized, sorry, those DEXs or those kind of dApps smart contracts, they have these kind of authorities. And if these smart contracts are bugged or being hacked, then these hackers have the authority to transfer or kind of just liquidate all of this funds from these smart contracts completely, to drain their wallets, after gaining the controls of, in this case, I was talking about the transit swap, right? So the hacker, they just need to get control of the transit swap router smart contract, and then to really drain all of the allowances for their for whatever fortune that they're trying to make. So the seeds that allowed the attacker to drain the fund were pretty much planted at the ERC20 standard level, right? So this era doesn't comes with like the problem of it doesn't really come with the problem of like the project itself or anything. It comes from the standard, the ERC20 standard level. All right. So we'll see later how Sui object oriented model can potentially improve upon this. All right. So if we take a step back and then think about what smart contracts are, they're actually very, very specialized. So I think I can kind of just really define it into these three different properties. They're really specialized to do three main things. First is to define new asset types. And the second will be to read, to write, and also transfer assets. And then thirdly will be check access control policies, right? Not everybody should be able to access certain things. Some things should have a control policy where it can be only accessed by someone else. So thoughts, smart contract languages should support first, safe abstraction for custom assets, ownership and access, because of those three properties that you see there. It has a very special needs when it comes to managing assets. And then secondly will be the strong isolation. It must be easy to write safe code. So I'll see an example of how access control can be defined in Sweet smart contract in a bit. And regarding of the strong isolation, it is because smart contract is source code that interacts directly with untrusted code written by motivated attackers. So we just want to make sure the risk is isolated between different smart contracts. So it is quite important there. So these are not common tasks in conventional languages that you see, in whatever languages that you code normally, and are not very well supported by existing smart contract languages as well. So this is where Move really trying to play here. It's like want to be specific on this, want to make sure this concept here, everything about this asset is well maintained. Well, I guess the limitation in previous smart contract languages. I'll just read them here. We got like 5 that we listed on this that we think is something that can be improved. So first will be cannot pass or return an asset as a parameter. So usually, like in Solidity smart contracts, when you pass the address of certain assets, and then you probably import the interface, right? And then using the address, you will, inside that functions, what you might do is using that interface saying, oh, this is the address, so please instantiate this smart contract. So that's what it will do. And then you can start accessing the property. And also the second thing will be cannot store an asset in data structure. Also, thirdly, will be allow a function caller to borrow an asset, declare an asset type in in contract A that's used in smart contract B, take an asset outside of the contract that created it. So some of this that we listed, we feel like these needs to be solved, and then Move is really and Move where what we're trying to do is to really address these sort of problems. And also one very specific thing that Move is directly aimed to solve is that within the world of Web3 and smart contracts, assets and ownerships are the fundamentals, to building the blocks. But the existing smart contract languages, they are really sort of lack of vocabulary and syntax for describing and interacting them directly, regarding of the assets and ownerships of certain, just ownership of certain assets, and also just assets itself. Like on Solidity, you always have to import some of the, like ownable, those kind of the smart contracts to make that happen. But also it is imported, it doesn't come native. And also, it has very limited functionality as well. So Move is pretty much the first smart contract language to directly address this issue. So yeah. So here, let's look at some examples of working with assets in Move first. So assets and ownerships, if you see here, if you're familiar with Rust, it's pretty much encoded in Rust-like linear types. It is very similar to Rust. It's very clearly defined if you're passing in a parameter by value or by reference or by mutable references. So there's a huge difference when it comes to if you pass it by value or if you pass it by reference or pass it by mutable references. I'll explain, what are the differences in a bit. And assets itself, you can pretty much just pass it like a parameter. It can freely flow across trust boundaries and between independent modules while maintaining its integrity and safety. All right, what does that mean? Let's look through these examples here. So the very first one, right? It literally says is if you give me a token, if you give me a coin, I'll give you a card title. And then if you look at the code itself, it's fun to define that it is a function. What this function's name is buy. So if I call this buy function, what I need to do is pass in the value coin, C, which is the type coin. So this is a type, a coin type sort of object that is passing in. And then as a result, if the function successfully executes, it's going to return you the car title, right? It's just like a real world scenario where we do trading, right? Let's say, I have something that I wanted to sell to you, or if I go to a shop and then I want to buy something, what I would do is I give you the cash and then you're gonna give me the the goods that I want, right? It's the same logic. So saying the second example, if you can see, is like if you show me your title and pay a fee, I'll give you a car registration. So this part is a little bit different. So if you see the very first example, it was give me a coin, and then I'll give you the car title, right? So it's all give. It's passing the object or the fortune or whatever the goods to the other person. You're passing it. But here, there's a show and here's a pay, right? These two are different. So let's look at it from the code perspective. So it's a function, and then this function name is register. And when you call it the car title, you don't need to give the value. You don't need to give the car title to this person. All you need to do is just show it. So having this and mark, it means you're passing the reference of car title, and then it's immutable. So if you don't have an MUT, like mutable abbreviation here, that means the car title that is passed here, you cannot alter its value, but you can be read. The purpose of this is to just read the value, right? So car title is given here, and then fee is the value itself is given here. So this is given, like just passed to this buyer or seller, whoever. But yeah, so this has gone out from your pocket into the seller, right? And then with both of these two conditions met and the function executes correctly, then you're gonna get your car registration as something that you're gonna be owning, right? It's going to be given to you. So this is move. This is pretty much I think why people call it move. It's like to move the assets to be able to do that. I mean, of course, we also have some other native syntax of move. I'll explore later. All right, this is the safe type systems. The type systems in move has built-in protections against various types of asset misuse. So if you see here, there's duplication detection, there's double spending detection, there's destruction. So a quick example, I'll just go through the double spending part. So it's like under this function, where C is given this value, and once the C is being moved, like moved out of this function scope, then is already not here anymore, right? And if you try it again, then the compiler is going to tell you, this is not going to work because you have already passed it away. You have already moved the asset away, the instance away from here. And if you try it again, it's not going to work because it's not there anymore. It is able to detect such problem. All right. So anyway, these kind of three examples, this ensures that digital assets behave more like a physical one, such that copying and destroying of an asset must be purposely done and well-defined. So this is, this is something very useful in move language. So every object in move can have up to 4 abilities. These includes the copy, which you can see here, and then drop. You also have key and store, right? So copy is pretty much, C must be created, so yeah. Okay. I kind of, hmm. Yeah, no. All right, I'll skip this part for now. Sorry. So this gives developers, fine grained control over assets behavior at the language and compile level. So I was really trying to give an example of here, but I kind of forgot how my example was look like. So I'll later share with the NUS group, and then you guys can take a look there. But yeah, I have a code example that you guys can take a look. But anyway, so these properties, they kind of give like a give the assets be able to be fine grained controlled. If you give certain objects a copy, a copy functionality, or maybe a drop functionality, or maybe a key or store, it means different things in here. So for example, if a type has both key and store, you know so let's say I have an object, right? And then it is given, I have assigned its property having a key and having a store, right? So it's like when I was trying to declare that, this struct K, and then it has the function key, or it has this property key. This will mean that this object itself can be searched in a global storage. So this is something how move works. It's like just like smart contract has their addresses, same with the move here is like if you have this key, then you can find this object using this object ID, sort of like an object key. Yeah, this might be a very new concept to you if you're first getting into the move language, but yeah, it has an object key specifically. So yeah. So if let's say an example will be if the object has both key and store, it's considered an asset and can be transferred. If you still have sort of a confusion regarding of the move, I think when we dive into Sui move, we'll have a better understanding there. But anyway, so another major feature of Move is that Move was designed with precise and efficient formal verification in mind. So formal verification is the act of proving and disproving the correctness of attended algorithm underlying a system with respect to a certain formal specification. So the Move Prover, which was created at Facebook and continues to be developed and maintained as an open source project, is fast and stable enough to run in CI and thus for Move and Move Power blockchain. Right. So if you don't know what CI is continuous integration. It's pretty much like whatever you want to push it you want to ship it to the customers, you want to test run it in CI. So that's like one of the pipeline that you want to go through before you ship your final product. So anyone can formally verify their Move smart contract code, not just experts with access to special hardware and software. It can be done locally, right? You have this, Move Prover, which is really strong to do that for you, right? All right, so a quick summary. The Move is optimized for safety and predictability. And also, it has safe math by default, and mathematically ill-defined ops, sort of like just making sure, something like an overflow, those kind of operations doesn't happen, like Solidity, because in Solidity, you have to import a safe math package or the smart contract to make sure that your additions or whatever smart calculations done there is not being overflowed. All right. And there's another there are some other summaries of this. So you can just take a quick look here. But in fact, this Move language itself, the Move VM, the Move virtual machine, is actually being used in 5 blockchains right now. One is Sui, us, and also there's Aptos, you probably heard of. And there's also Zero L. There's also Starcoin. Starcoin is pretty huge in China, I think. Their proof of work. And lots of just interesting from existing and emerging chains to implement Move VM. So it's an incoming trend here. So Move's vision is really to trying to make itself a JavaScript of Web3, right? To make it really accessible for all developers, and also being strong language that can support any kinds of smart contract applications. All right. Here, like a vector. What do you mean by string define?
Like for instance, like the type of string, is it like a byte string, or is it, because I don't looking through the Move documentation, I don't see like a primitive type for string.
Yeah. So pretty much, yeah.
So is it like a what kind of what type is it, like how do I define a string, for instance?
All right. Let me share a link with you. All right, you know what? I'll do it later. I'll do it later. But yeah, that's a good question. Yeah, I need to find the documentation there, and then I'll share you the link. All right. So now we dive into SweetMove. All right. So for SweetMove, what we talked about just now, is the core move part. And then now we want to talk about the sweet move part. So before it's kind of like DM style move that you see in other projects. And the sweet move style, it can be seen as a dialect or implementation of move that combines move with an object-centric programming model and accentuates the advantages of move even further. All right, so here we're really trying to accentuate the object-centric programming. Yeah, so if you see here, it's pretty much a sort of an example, a DM style move example of transferring an NFT with a lockup period. So if you don't know what lockup period is, it's pretty much to check if certain assets has been stored or has been saved for enough time to be able to transfer or being upgraded. And here, let's first start with the very first part. First is trying to define a table to hold multiple NFTs of the same type. So if you see here, pretty much this asset is called a cool asset store. Under this, you have sort of like a table struct, and then it can be accessed. This table is key is table token ID, and then you're gonna get the cool asset itself. Right? This is a table that stores everything. So you first need to define the struct here. And then you need to implement a function that how you add these recipients by so it's pretty much just by adding a new table with associated to an address, then that's how you register this recipients into this table into this multiple NFT struct table. All right. And then this function is where you do the transfer, where it's going to look up and then see if you're one of the recipients, and then if the sender actually has it as an asset, right? And also your lockup period is passed, then you can do the transfer. And then there's also a lot of detailed functions that is done in between. We're just going to go through them one by one. So first part is going to look up and remove assets from the sender, right? Before you give them something, you first need to remove it from your address. But even before that, you first need to check if I actually have it or not. Right? So here, what it's trying to check here, so the signer, right? The sender here will be the one who owns the assets, and it's going to check if the sender actually is being registered in this database, right? And then under this database, it's going to check if it has actually if it actually has a certain asset. So the asset that is trying to pass the token ID here, right? This asset I'm trying to give it to you, do I actually have it or not, right? And then once it's checked that it actually has it, then it's going to remove it, right? So this is being removed. After it is being removed, it's going to check, okay, now let's look up the lockup period, right? See if it has locked enough. Yeah, if it passes the time frame already, then you can actually do the transferring. And there you're gonna go, what you're gonna be doing is, well, first you're gonna check if the recipient is registered in this database, see if it can actually receive it, if it has the authority. And the second will be to really just to check like if it has sort of this token already. And then if not, then we can pass, like we can transfer the assets. So these are a lot of steps for a very, very simple task. And the problem here is that transaction API and also the global storage API are not asset centric. So you just have to use all of these different tools to help achieve what you really want, as in like you want to transfer assets. So you need to check all of the different functionalities, different features of your assets there. So ideally, what we really wanted to do is to just use the asset itself instead of using other functions to operate how the assets should behave. Something like just passing this asset directly into a transfer function and then transfer directly to the recipients. It's just that will be just like real world scenario, right? I have this asset, I just give it to you, and then you receive it. That's all. So that's how Sui style of move is being implemented. So if you take a look here, it is very, very simple. It's just 2 lines over here. So for the code transfer function, compared to the previous one, it probably had like 10 or something lines, where at first it checks, okay, has the time passed? It has the lockup period passed. If it has passed, I'll just call the transfer function, where it will directly deal with the assets and then transferring this asset from me, because I'm the sender, to the recipient. So what are the differences here? You can see first is like defining table to hold multiple NFTs of the same type. So no longer needed Sui addresses distinguishes objects by ID, right? This is something that I touched a little bit before. So it's like different objects, they have their own individual IDs, right? So, and then under this ID, you can just access this object by this ID. So just like accessing the smart contract via under an address, same thing here, you just need an ID. All right, so you don't have to specify another hash table or table like to maintain this structure. And the second thing will be recipient option by publishing table. So that was how it was before, but here it is also not needed because it's like any Sui address can receive any object type, right? It's just like an asset to you, right? So under my address, I don't need to say, this is this kind of to object. I don't need to specify that, I needed this kind of object, under me. So I need a smart contract that can really host this object itself, right? No, I don't need it. You can just pass that object to me, to under my address, and I'll just be able to receive it. Yeah, whatever assets under a certain address in Solidity. And then third will be the lookup plus remove assets from sender. This the Sui runtime does this for you, so you don't even need to bother to do the lookup and the remove assets. Especially in here, the transfer asset to recipients, pretty much is what it does is looking at that if you being the sender, do you have this asset or not? If you do have it, you can just remove the assets from under my address and then transfer it to the recipients. Right. And then yeah, you check lockup period. So here, yeah, and then transfer to the recipients. Okay. So C transactions takes object ID as inputs and the runtime. So what it really does is it resolves each object and then checks that the transaction sender owns it or that the object is shared. So if the object is shared, then you don't have to own it. You can just access it, right? And then thirdly, we'll be checking the object type against the entry function signature. So it's like if you're passing certain things to a function, right? Of course, it needs to check if the functions, whatever the function is trying to take in, is something that you're passing in, right? And then calls the functions with object arguments. So these are sort of like the pipeline here. And then transaction effects. C transactions can create or it can mutate or delete objects and as some of these effects. This is what transactions in Sui can achieve, right? You can create, mutate, or delete objects. Also, transactions in Move, have an all or nothing semantics. So if an execution of a transaction is abort at some point in Sui Move, so even if some changes to object had happened already, or some events had been generated prior to this point, none of these effects persist in an aborted transactions. That means, it's going to be reverted back to what it was before. Yeah. So ownerships and access in Sui Move, right? So types of ownerships here, these are 3 different conditions. So if the object O is owned by an address A, then only a transaction signed by A can be used, can use O, the object O, right? So this is the ownership and the authority. And then secondly will be the another object P, where a transactions that includes O and the entire central chain of O can use O. You can kind of understand it as in like, this object P, is probably inherited, probably has inherited O, maybe just has some not it doesn't have like that direct connections, but it has some sort of connections there. It's kind of like inherit those kind of connections. Then yes, you can use O as well. So as an object P, right, from the object P's perspective. And then if your object is shared, then yeah, anyone can use O. It's being public, everybody can use it. So access express in Move syntax, you can take a look here. This is where I was really digging into in previous slides, as in like how you pass in the value, it means different things. So this is very Rust-like. So if you just pass in the value itself, it means you can transfer, you can delete, you can read or write, these assets or whatever this, whatever these sort of the variables that you pass in. Okay. But if you pass in with an and mark and the mute keyword, that means you can write and read. This and mark here, if you only have these and mark, it means you can only read it. It's like a reference. But reference plus mutable, that means you can read and also write. You can alter the value. So one of the consequences of Sui Move's object-oriented approach is human readable signing requests and permissions. So as we mentioned at the start, the transit swap was made possible by users signing all these infinite ERC20 approves to smart contracts, because Ethereum smart contract interactions rely heavily on blind signing, which all of you should probably have some experience with. There are some attempts to address this issue, such as EIP 712, but it's not a complete solution. So in Suite, because of how its objects are maintained, it's possible to give users Android and iOS style permission requests for interactions with objects. So what do we mean by Android and iOS style permission? So kind of like, if you see an example here, so let's say there's sort of like a giveaway of 8 coins, right? And you need to interact with the smart contracts to receive your 8 coin, right? Sorry, receive sort of like a free airdrop or something. Then its condition is like, oh, I want to check how many 8 tokens that you have. If you have enough, then you can receive it. Well, most buyers, they wouldn't know anything about the codes, but from the Suite network, the Suite contracts level, its security, it can already detect what this function will do before you requesting you interact with the smart contract functions. Like before you interact with it, it can check what its intention is, because you can literally see it from the very first line of its definition. Right, so this function safe giveaway, this is the correct version. What it does, it only pass in using the reference of your token, right? It's only going to read it, right? So this, if we translate it into English, will be this asks wants to read your 8. Is that okay? Yeah, that's fine. You can read it because that's what I want you to do, right? To check how much I have. Then if I have enough, then you give me my giveaway. But the malicious one will be, without this reference mark, where, it really means that you need to transfer the board ape. This app wants to transfer your ape. Is that okay? Of course it's not okay, because once it's transferred, you don't have it anymore. So this creates a much more secure environment for users while interacting with smart contracts. Users, they know exactly which object transactions it's asking permission for and what it can do with the object. But yeah. So that has been it regarding of the Suite move. Yeah, it has been quite long. I don't know if you guys have got everything yet. But yeah, will be the last session. We'll talk about the Suite system. In this part, I'm also still learning, but I'll try my best to explain as much as I can. So here is like we have been talking about the move and the Suite move language until now. Those were the core. But of course, the Suite network, it has its own very unique features as well. Which really combines with some of the special functionalities of Suite Move as well, the object-centric part. See how the Suite system really utilizes that into a more parallel blockchain, more like faster blockchain. So before we dive into what Suite system is really like, I think it's worth taking a look back into how the classic blockchain structure is like. So if you're familiar with blockchain, then you probably know the entire blockchain scheme is like they do a global consensus every single block, most of them at least, not every one of them. So usually how it happens is like you have different transactions. Looking at the left side of the graph, you have transactions requested from all the clients, from MetaMask maybe, or just from any sort of interface, and then sending the transaction request to the blockchain nodes, as in the miners or maybe just the validators, and they'll receive it, but they're not going to process the transactions right away. They're going to store these transactions into mempool, right? So that's where all the MVV and all those stuff are coming into play. But yeah, just based on any sort of selection roles, it could be, if you don't like MEV, but that's still a thing. So a lot of different nodes and validators, they choose your transaction order based on their MEV potentials, and also just the normal gas fee selections. So, and there's probably other ways of selecting as well. but yeah, based on these rules, you select the transactions that will be included in the next block, right? You sequence them into a certain order and then make it into a block, right? And then you kind of reach consensus, right? If you mine the token, if you solve the problem, then you're the one mining the token. Or if it's your turn to produce the block. Anyway, any sort of consensus protocol, but just following that protocol, your some of the node is going to produce this new block and then broadcast it to the entire blockchain network. That's going to take a while. And then whenever the blockchain receives it, is going to execute it, is also going to verify it to make sure these transactions are correct. Okay, so once these are done, then is going to all of the results, all of these will be added to the database, right? As in like merge into the Merkle tree, right? Indexing them to save it so that it will become a storage state. But yeah, this is pretty much the entire pipeline. So all of the transactions when it happens, it's about the from A to F all the way. So yeah, the classic blockchain architecture requires all transactions to be sequenced and totally ordered. It's not like you can't do just AB for one sequence and then C to F to into another sequence. These all have to happen in the same ledger. Then execution of each transactions in that queue and requiring global log, all these kind of problems. There are several issues with this. It's like the BFT consensus on all transaction result in very low throughput, because it's a global lock, right? And the entire process is highly sequential and serial and has a high degree of head of line blocking. So we asked ourselves, how can we improve upon this? Yeah, so the SWE system design goal is the following, this one sentence. So a replicated auditable transaction processing system that allows write constraints by user-defined smart contracts and public reads, and that is robust to Byzantine failures. So yeah, what is this, right? I'll explain a bit. So to understand what that statement really means, there are three key ingredients to really follow. We're gonna look at each of these 3 points more closely. So first is express computations and objects and allow parallelism. Second will be to avoid consensus when possible, run very scalable consensus when required, and then to do housekeeping after finality. All right, housekeeping is a very very subjective term. It's not very clearly defined what housekeeping is. I'll explain in a bit too. All right, so the object versions parallel execution. What does this mean? Right. So the processing conditions for both transactions and certificates ensures casual execution. An authority only votes by signing a transactions if it has processed all certificates, creating the objects. The transactions depends upon both own, shared, and read-only. This imposes a casual execution order, but also enables transactions not casually dependent on each other to be executed in parallel on different cores or machines. The left side really shows, how own objects are executed in parallel, and the right side shows shared objects, how are they being operated, right? So, if you look at if I dive in a little bit deeper here, if you look on the left side, you got IDX, the core 1 here is running IDX object, and then core 2 is running the IDY object. So this means, for example, I have certain object under my address, and then this object, I have interacted with it twice. right? So these two transactions, they're kind of dependent on each other because they're happening on the same object. So they have to be run by the same core, right? Otherwise, like if you run, transaction 25 in core 1 and then transaction 26 in core 2, and these will bring different results. And also it might conflicts with, how they accessing certain variables or data within the IDX object itself. So, and there's no lock regarding of that, right? So we want to make sure, okay, for the transactions that is happening on the same object, we want to make sure they're in series, they're not in parallel. But between different objects, if their states or whatever their certain conditions, they do not interact with each other, they can definitely be separated, right? They don't have to run together. To run the IDY transaction 5, you don't have to wait until IDX 25 is finished or even before this. There's no such constraint. You can just run it freely without thinking about there's a IDX that is operating in the background. Right? So something like that. This is where you can really separate the transactions into a parallel form. Right? You can run both of these at the same time. And on the right side, it's very similar, but just for the shared objects, as in if you look at on the top and the bottom, it's just very similar thing. Both IDX and IDY, they're shared objects, and they have requests from all of the different clients or all the different users. And they'll be sending in requests, say, oh, I want to get this done. Someone will say, I want to get that done. Depending on how they want to order the transactions, this can vary. It really depends on the node and the validators, how it benefits themselves. But these transactions will come in series for sure. But between these two shared functions, as long as they don't have any functionality that do with each other, then they can just run in parallel. Right. So similar idea. So we believe that in many types of applications, the vast majority of transactions, they really fall into the first category on the left hand side. These are also called a single writer application. So they include things like a P2P payment apps or Web3 games, Messenger, or even social apps, DID, etc. These kind of single writer applications. These can be done very efficiently via the left-hand side way. So the next question is, primarily is transactions that the owner can determine the sequence of events. So yeah, what this really does is like, what are some of the transactions that can avoid, consensus? That this is something that we want to make sure, because yeah, if it doesn't need a consensus right away, right, then you don't have to do it right away so that it saves time. Otherwise, every time if you want to reach a consensus, it takes a lot of time, right? And also for different nodes to sync up the transactions, then you require a global lock, right? So you want to make sure these kind of things happen as less as possible. So on the other hand, the transactions involving shared objects, these are some of the transactions, like they do require the network to kind of reach a consensus, and then to sequence them to make sure each of these involve actions that happen in the shared objects, they're well indexed in the database so that whenever there's other requests regarding of this object itself, this shared object itself, they have the latest updates of the object state, right? So to really distinguish these two, like, okay, what's not needed to reach consensus, what's needed to reach consensus, the protocol we use for it is called the narwhal, and the bullshark is pretty much a dark-based mempool and consensus layer. This is where we do the magic here. Right. So what can happen after finality? All right. So Sui design aggressively to reduce the bottleneck and point of synchronization. Right. This is something that I've been explaining in previous slides over and over. So requiring global blocks within the authorities is something that they're trying to eliminate as much as possible. So processing transactions is cleanly separated into two phases, namely, first, ensuring the transactions has exclusive access to the own or shared objects at a specific version. And then second will be sequencing, subsequently executing the transactions and committing its effects. All right. So yeah, so you're seeing like what is trying to understand each of these transactions. Are they done via an own object, or are they done via a shared object? And then once categorized, they will do it differently. But there's going to be a graph in the later slide. So yeah. But if we look on the right side, it's where the housekeeping thing comes into play at the very last. All right, so what can happen later? These are all the housekeeping stuff. So as listed, so something like gather transactions and block, this doesn't have this doesn't happen. This doesn't have to happen right away, right? You can just keep your ears open, right? Keep your eyes open, just listening and then seeing these transaction requests to send to you, and you just keep on doing that. That's fine. You don't have to stop it, or you don't have to make it the priority. And then stuff like gossip to update full nodes, right? You don't have to do it immediately at once. Yeah, a lot of people are having issues installing Sui binary from doc. Yeah, we have a community. Here, let me take a look. I would suggest if you could add my Telegram later. I have a slide of my Telegram ID, and then I'll add you to our developer Q&A group, and then I'll answer you there. But I think it probably has something to do with your Rust environment, or maybe. But yeah, we can dive through there. Thank you for the question. All right. But yeah, the remaining, it's just some of the housekeeping thing you can do. You can just take a quick look. I'm going to share the slide later. And Sui validator architecture. Now, this part is something that I'm still trying to learn. So hopefully I'll be able to explain in full depth. So if we take a look at the Sui validator nodes operations, sort of like architecture. So firstly, a user with a private key, they're going to sign the transactions. They're going to create and sign a user transactions. Say they want to mutate sort of objects they own or maybe shared within Sui, right? And then this will go through the sort of the broadcasting phase first, right? Because your transactions, you need to broadcast it. You need to tell it to all the nodes out there, and then make sure they start to collecting your transactions and then process it, right? And the user transactions is then sent to the Sui authorities, and each check it for validity. Right, they're gonna check if the transaction is valid or not. And then upon success, sign it. So these authorities are going to allow it, say, oh, this is good, this is fine, right? They're gonna sign it and then return the signed transactions to the client, right? And the clients are the nodes, all right? So the clients collecting the responses from the quorum of authorities to form transaction certificates. The transaction certificate is then sent back to all authorities. And if the transactions involve shared objects, it is also sent to the Byzantine Agreement Protocol, which you can see here. So if does not need consensus, which means this is just a solo object operation, it's not a shared object, You can just run it directly. You don't have to look for consensus there. But if it's a shared object, then you have to go through this consensus part. Right. And then pretty much what it does, authorities check the certificates, and then in case shared objects are involved, they also wait for the agreement protocol to sequence it in relations to other shared object transactions, because there's also other shared objects transactions being pending. So they want to kind of just sequence different shared object transactions to make sure, just like normal blockchains, right? But it needs to have certain orders. And then to execute the transactions and summarize its effect into a sign effects response. So once all of these are done, it's going to once a quorum of authorities has executed the certificates, its effects are final. Once these are all final, then client can collect a quorum of authorities responses and create an effect certificate and use it as the proof of finality of the transaction effects. This gets committed to the global write ahead law, which means this is being stored into the database at last. And once all of these are done, the housekeeping will keep on beginning, right? So which is listed on the previous slide, the right one. These steps will keep on going. Yeah, so object-based fee market is something we kind of think is needs to be added to our blockchain system, because to design this parallel execution at the system level, it's definitely not enough. We need to have sort of incentives, creating contentions, must also have economic, disincentives for users and programmers, right? Otherwise, this will not run well, right? Because shared objects or your own objects, they certainly have different effects when you try to run them. So the fee market design, its goal is really to design pricing scheme such that maximizing the fee revenue equals maximizing throughput. This ensures that when your node is running, then what it's trying to do is trying to maximize its income, right? And by doing so, we're hoping the service they provide is also maximizing the throughput, the performance of the entire blockchain itself. And the gas price for a transaction is proportional to the hotness of the shared object T touches, tracked by the validators. So if the shared object is too hot, as in it's as a hot node sort of, hot node is the Web2 concept. Let's say just a very hot object, right, is being accessed so many times. And then it requires a higher gas fee to access it, because there's so many people are pending for such requests. And contentions on shared objects only affects prices for transactions touching O, right? So unlike on Solidity, right, or just Ethereum, let's say, there was one time I think Ape was trying to do an airdrop, off their tokens or something like that, or just like some of the protocols they're trying to sell their NFT, right? The entire network get jammed up, right? The entire network will have a really high gas fee, so that other operations during that time, maybe I just don't care about this NFT or airdrops. I just wanted to do like a normal uni swap transactions, but I wouldn't do it because the gas fee is just way too high. Although I'm not participating in those transactions, there's really this really kind of affects normal day-to-day users from using blockchains. But on the other hand, over at Sui system, only the hot objects gets a higher gas fee, but the normal operations that you would do on the other objects, other less hot objects, their price fee is based on the hotness of them individually. So this is something cool about them. And yeah, so pretty much means other transactions are unaffected, eliminating noisy neighbors, right? So the worst case scenario for this system will be if we see on the top, it pretty much is every single transactions touches the same shared object O, in which case, performance of suite, it degrades back to a traditional total order based blockchain, right? There's no more parallelism going on here. Everything is just in series because it's requesting the same object over and over again. Everybody has to wait. But that's pretty much like the traditional one. So the summary here. The problem suite is tackling is safe, low friction, consumer grade wallets, safe, broadly accessible programmability with Move, high throughput, low latency agreements horizontally, scalable execution and storage, affordable replication via sparse nodes, incentives for reducing state bloats. Right. These are really abstract level of explaining what I was saying before, but these are some of the major points. And currently Suite is indefinite now. Testnet is coming very, very soon. So if you're interested, feel free to, just stay tuned. And then I think by the end of this month is what we're shooting for. But yeah, once the testnet is out, you can do a lot of cool stuff with it, just like how you interact with the Solidity smart contract, Solidity testnets. It's gonna be something very similar to the later mainnet launch environment. So feel free to explore there. All right, so thank you for your time. And that's the end of my talk. Here are some of the contacts that you can see. Sorry, I forgot to change the slide. On the right side, if you speak Chinese, if you have WeChat, feel free to scan this right-hand side QR code to join. Otherwise, this is mainly for the Chinese developer community. But yeah, if you wanted to get into this English-speaking developer community, feel free to ping me on Telegram. This is my Telegram ID, Brian Seong, literally my name. Or if you have any questions, you can also email me. This is briansong@mystenlabs.com, or just send me a Twitter, right? Twitter message, direct message. I'll check it there, right? And then, but on Telegram, if you message me there, I'll add you to our developer community. And then you can just have different, you can see how the others are answering some of your questions there. But so far that's about it. Thank you guys for your time.
Hey, thanks, Brian, man. Thanks so much for the insightful sharing. I think before we go, I think we have a question from some of the participants. So let me just quickly share my screen.
Do you want me to end sharing?
Yes, please. Thank you.
Okay, well, I just want to make sure everybody has got the information.
Yeah, that was great.
Okay, so yeah, this is my Telegram, Twitter, and email. All right. Just wait for like 5 seconds. Okay. Well, thank you. I'll end the sharing.
Can see my screen, right? Yeah.
Yes.
Okay, great. I think the first question we have is whether Mysten Labs is opening up for full-time or internships for roles in Singapore. So can we join as students in roles such as SWE, DeFi product manager, and trading roles, etc. So maybe you could help answer that.
So if you're trying to join as a software engineer, we don't currently have an opening yet. Because right now we're still working really hard to launch the mainnet, and so this part really requires, I guess, more experience, more of a industrial level developers to really work. So internship regarding of this is probably not, like, there's no opening regarding of that yet. But full-time, yeah, you should be able to find. Yeah, there's a lot of links that I need to share today. Let me find it. Career. Mm, here you go. Yeah, this time I found it. All right, let me just share it in the Zoom link. So if you see here, it has all the job listings that you can take a look, right? We don't have a Singapore physical presence there, and I don't think that's in mind. Yeah, so we would hope to, expand it, of course, but right now, I think our physical office, we only have one at California, and also another one over at Greece. Yeah, so these two, we are looking for some developers locally. But whoever's trying to sign up for to work for us, majority of them, like including me, we're all remote. So yeah.
Okay, great.
And regarding of the DeFi PM trading roles, I mean, I'm joining as a student, right? I'm a student myself. I'm doing a master's degree, but I have been doing developer relations before, so it's very natural for me to join as the developer relations there. So it's like if you have some sort of very similar experience and they have openings there, feel free to apply for it. But yeah, just check out the link that I shared in the Zoom.
Okay, thanks for sharing that. Perhaps the next question. How do you recommend picking up blockchain development?
So if you're trying to picking up from Move language, it might be a little bit difficult for you because it's like if you don't know Rust, then it takes some time for you to understand the ownership and those kind of concepts. It's not like hugely hard, but it's something that you definitely could will take some time to explore and get used to. There are a lot of examples out there regarding of Solidity. Just to understand Solidity itself, it takes quite some time for a lot of people because the language itself is not hard. But in order to really understand it, you need to understand blockchain. You need to understand, how, what really is smart contract and how it works with the blockchain. And that concept itself really does, put a hard time for a lot of beginners. But once you really get the sense of it, get the hang of it, then I think you will be good to go. That's first. And then second will be just learning the smart contract languages, right? If you know what blockchain is, how it operates, then you learn about how to interact with them, how to build programs on top of them. That will be the Solidity or the Move language that I talk about today. And yeah, just those two are the main essentials. And after that, if you want to look into how the clients, how the users will be interacting with the smart contract language, the blockchain, that is pretty much from the user interface side, right? Usually the application developed will be on your website is going to be like using React.js, those kind of frameworks. So I definitely recommend you to check out. You can do it in TypeScript or JavaScript or whatever, but as long as like you learn these frameworks and then you use those SDKs that provide it from Solidity or Move, right? Then you will know how to interact with the smart contract. So these are the three major components I see. Like you need to get yourself started. Like first, understand what blockchain is, how it really operates, right? What is the consensus, stuff like that. And once you have that, right, you want to tackle into the smart contracts, right? Which mainly is the two ecosystem. It's the either Solidity or non-Solidity. And among non-Solidity, I'm heavily leaning towards the Move language. It is very, very strong and safe, as I explained in the previous slides. It's something that Solidity cannot achieve at the moment. It's unique benefits. So it's worth take a look into. And then third will be the front end, how it interacts with the smart, how your program interacts with the smart contract, right? I guess it's not front end, it's more like the SDK that you would use to interact with the smart contract. It could be on the back end, it could be on the front end, it could be just a microservice, whatever. But you need to know how the Web2 application, Web2 programs or codes will interact with the smart contract.
Okay, I think that's great. Thanks so much for answering all the questions. Yeah, I think we actually can wrap up our session already. So yeah, once again, thanks Brian for leading us through this very insightful sharing session. And yeah, thanks everyone for coming also. So yeah, I guess I will see everyone around and take care.
Oh, thank you. And
Yeah, thank
also
you.
whoever asked me about the stream question, ping me on Telegram and then I'll answer you there. I just need to look for that link. I have an example. All right, thank you.
Thank you. Bye
Mhm.
everyone.
Bye-bye.
Bye.